Hello guys, welcome back to Maths on African Motives. Still working on our mathematics N5, working on the differential equations in this case, which is the application of our integration again, but having also as our derivatives again. So we are given on question number 6 of April 2023 exams, the first part of our question, which is 6.1, to determine the particular solution. So take note, we are dealing with what particular solution. That means you are supposed to determine the constants on that condition. You must determine the constants or the constant depending with the constants that you have on that differential part. So the first part, as you can see, it's a first order differential equation whereby we are given y0 is equal to 2. What does it mean? We are given the value of y, which is 2. So they are saying here the value of y at this moment is equal to 2 when x is equal to 0. So that is the value of x at that moment is equal to 0. So just like f of 0 is equal to 2, x is 2, y is equal, x is 0, y is equal to 2. That is the concept there. So remember, from our separating of variables, in order for us to determine the particular solution in this case, we are supposed to separate these, all right? Take the x to each part, the y to each part in this case. But as you can see, it's a mixed part that it's difficult for us to separate for the way that it is right now. So what are we going to do? Let us take our expression, dy dx is equal to, we play around with our expression, try by all means here to obtain x to one side and y to one side. So what was the condition here? We can do that by factorizing. We can do that by factorizing. So okay, we can take the part that has got x, here there's x, here there's also x. We are going to collect our terms. That is, we are going to have 2x plus 2x y in this case. We are remaining with minus 1, and here we are remaining with minus y. So we're going to have minus 1 minus y like this. All right. So from our factorization concept, like what I'm saying, we can apply our factorization concept whereby we have to maintain the x on each side, the y on each side. So here we can apply our factorization by grouping into 2, since we've got 4 terms. That is why we have to rearrange, then we group into 2. We can see that x here is common. So that means we can factor out our x in this case, which is common. You can factor it out as 2x. You can factor it out as x, so you can factor it out as 2x, since 2 is also common. All right, so this part, if you divide 2x and 2, x is going to be a 1. 2x and 2x cancels, you remain with a positive y in this case. So meaning to say, on these 2 terms, we are supposed to factor out a common term so that we remain with the bracket of 1 plus y. So we're going to factor out -1 so that this becomes a positive, y also becomes a positive in this case. So since this bracket is common, 1 plus y is common, we are going to factor it out. So if we factor out 1 plus y in this case, it means we remain here with 2x on this part, we remain with the -1. So this is what is going to represent your dy dx. At this stage, you can properly see, all right, I can do separate this because I have the y on its part, I have got the x on its part. So what can I do to separate my variables? In this case, we can cross multiply first. All right, that is going to be 1 times dy, which is dy is equal to this whole part of 1 plus y into 2x minus 1 is going to multiply our dx. But we still have the part of y on the side of x, which is not supposed to happen like that. This part of y is supposed to be written where there is a y there. So what are we going to do? We are going to divide by this bracket to this side where there is a dy, so that the variables of y are taken to one side of the differential equation that we have. So that means we are going to have dy over, we divide by this bracket, which is 1 plus y, or same as y plus 1. It's the same thing. 1 plus y is just same as a plus b, b plus a. It's just one and the same thing in this case, all right? So this one we have divided, so we no longer have this part. we are remaining now with 2x minus 1 dx. So that is, we have separated the part of y to its own, part of x to its own, so that we can be able to integrate this side. By integrating, we are now having the values that can represent x and y in this case. Take note on your integration there. This is same as 1 over y plus 1. It's the same thing. So it simply means here, if you do not want to confuse yourself, you are going to write it as the integral. Since you are going to introduce the integration, so you're going to have the integral of 1 over y plus 1 like this with respect to y, which is equal to, we introduce the integration here, which is the integral of 2x minus 1 with respect to x. So that is the idea of this part. All right, remember that if we are integrating 1 over a function, is going to give us ln f of x. So we are going to have ln of y plus 1. So this one is going to give us ln y plus 1, which is equal to, we integrate this part, this is 1, we add a 1 in this case, so it was going to give us 2x to the exponent of 2 over 2. 2 and 2 was going to cancel. That means you are going to obtain x squared in this case from this part. All right, so this was going to give us x squared. We integrate minus x with respect to x. That will be minus x plus constant of integration in this case. So this is where you are, whereby you have determined the general solution in this case. This part that we have just determined here is our general solution in this case. So we are talking about the general solution. But our question is not to determine the general solution. No, the question is for us to determine the particular solution. So that's where we go back to the information that we are given before. That is y0 is equal to 2, where I said is x is equal to 0 when y is equal to 2. So x is 0 and y is 2 at that moment. So you're going to substitute what we are having on our general solution. We are given that at this moment, we said y is equal to 2 when x is equal to 0. So that means we are going to substitute where there is y, you substitute a 2. So this was going to be ln 2 plus 1, which is ln 3, is equal to, wherever there is an x, we are going to substitute as 0. So we are going to remain with the c. So c is equal to the ln of 3. So therefore, we can conclude to say that the ln of y plus 1, the ln of y plus 1 is equal to x squared minus x plus the constant, which is our constant in this case, is the ln of what? The ln of 3. So this now that we have just determined here is our particular solution. So there we are talking about the particular solution. This is where you have determined the value of the constant. Our constant here, which was C on the general solution, we have a constant, but on the particular solution, you have the numerical value to that constant that you are given. So here, that was idea. All right, so let us check the other part of our question. 6.2 was now to determine again the particular solution of this whole part that we have. Again, we've got a statement, just like the previous part, that you also need to analyze and check how does this operate. We are given that dy dx is equal to 0 when x is equal to 1. So this is a straightforward part that x is equal to 1, but at that moment, dy dx is equal to 0. That's how we take it. If you check this one, it's simply from our previous case. Here, from our previous case, y0 is equal to 2, y1 is equal to 2. So we are simply having one and the same approach, just like the previous part where I said it's x here and y. So we're given the value of x being 1. At that moment, y is equal to 2. So this part is the one that you're going to use, and this is the part that you're going to use on dy dx. So let us check how we are supposed to find y in this case. So the was integrate, that was the concept. It was just to integrate. We're supposed to integrate this. Remember, this here we are talking about the second order in this case, whereby we are supposed to have as the second derivative of y with respect to x is equal to a function of f of x. So if we check, we are supposed to have, or we are supposed to remain with this part here of dy dx as a function of what? As a function of x to the other hand. So meaning to say we are supposed to make this the subject of the formula. So what are we going to do here? We are having this, which part of x, the part of x here, which is multiplying. This part, as you can see, it's multiplying. So we are supposed to divide by it so that we remain with the second derivative. Like I'm saying that we are supposed to have our expression as the second derivative of y is equal to. All right, so let us see what was going to happen if we divide. We're going to have the second derivative of y with respect to x, which is equal to, here there's a 1, so it was going to be 1 over, we have divided by this whole part here so that we remain with the second derivative. So we have divided by 1 over, in this part, that is x plus 3 squared minus 2. So this is the part that we have divided with. So if we check here, it's just an inverse that we are having. Remember from our exponents there, 1 over a over b. It's simply the inverse of a over b, which is going to be given as b over a. You simply interchange these numbers. So if you are given 1 over a certain fraction like this, you simply interchange that fraction. That's the inverse of the fraction. So meaning to say, we were going to have our second derivative of y with respect to x as this part is now on top. So we're going to have x plus 3 squared like this minus 2. We are having minus 2 like this, 1 like this being divided. But dividing by 1 does not even affect our question. If we divide by 1 like this, it does not even affect our condition of the question. So what am I trying to say is that instead of you having this expression, instead of you writing this expression the way that it is like this, you can simply write it as the second derivative of y with respect to x is equal to x plus 3 squared minus 2 like this. We have divided by 1, but the concept is that the inverse, you have to interchange the numbers. It was a over b, now it's b over a. You interchange, that is 1 over a condition. So now we can integrate both sides. But before that, we can see that there's a bracket there. Just expand your brackets. All right. So remember that if you are adding from this concept of our perfect squares, a plus b squared is equal to a squared plus 2ab plus b squared in this case. So here we can apply this concept because we have got x plus 3 squared in this case. So take note what we have, we've got a squared in this case. Whenever we have a squared like this, we can expand our brackets normally, or we can use this concept, all right, whereby we are going to have a squared, which is x squared in this case, plus 2ab, that is 2 times a times b, which is going to give us 6x plus b squared, which is our b raised to the power of 2, which is 9. Then we subtract a 2 in this case. All right. So thus we are going to have the second derivative of y with respect to x is equal to, collect your like terms. So we are going to have 9 minus 2, which is going to be a 7 in this case. So as we can see, we are having a normal algebraic expression whereby I said the second derivative is equal to f of x. So how now are we going to solve? You have to integrate both sides. Now we can integrate properly. We're going to integrate this part with respect to x, integrate this part with respect to x, knowing that if we integrate with respect to x, the second derivative, it is going to give us the first derivative dy dx. Then on the other hand, you are integrating each part as it is, all right? So we are going to integrate this part here. That's x, we add 1. So if we add a 1 here, this will be a 3. So that's x to the exponent of 3 over 3. All right, we move on to 6x. This is already a 1. If we add a 1, it's going to be a 2. So it was going to be 6x squared over 2, which was going to be a 3 in this case. So this was going to give us 3x squared. 7 is a constant with respect to x. It is going to be 7x plus the constant of integration. So in this case, since we have two values that we are going to work with, we can have a, then the other one can be a b in this case. All right. So this is our first part of our general solution, but here we are given a condition for dy dx and a condition for the point A. This is the one that we are supposed to take on this part. All right, let us get back here where we are given the condition of dy dx is that dy dx is equal to 0 when x is equal to 1. This is the part. Dy dx is 0 when x is equal to 1. So you work with the dy dx because you are having this expression, you are having dy dx. So we are going to substitute. We said dy dx is a 0 in this case. When x is a 1. So it means wherever there is x, you are going to substitute a 1 in this case. So this part at the end was going to give us, if you simplify this whole part, if you put a 1, this whole part on the right-hand side, it was going to give us 31 over 3. 31 over 3 plus a. So to find a, transpose this to the left-hand side, it becomes a negative. So that's negative 31 over 3 was going to be equal to a. So this a that we have obtained, we are going to substitute now into this a that we are having, all right? So that is how we work with the particular solution in this case. So we are saying that dy dx we are going to rewrite as it was before, dy dx, but this time it is equal, everything is going to remain as it is, x to the exponent of 3 over 3 plus 3x to the exponent of 2 plus 7x plus a, which is our a in this case is the one that we obtained. We obtained what in this case? Negative 31 over 3. So we're going to have negative 31 over 3 like this. All right. With the value of a that we have, we are going to integrate. Remember, our condition is to have y at the end. So we integrated the second derivative, we got dy dx. With the same concept, we are going to integrate this side. The moment we integrate this with respect to x, we are also integrating this side with respect to x. So if we integrate from our dy dx, that's where now we are going to obtain y, all right? So this time, if we integrate this, we are going to obtain an expression for y. So here we are just going to integrate, all right? Remember, our integration is not going to change. We add 1, which is going to be 4. So it's going to be x to the exponent of 4 over the new exponent is 4 multiplies the denominator because there's a number here. So it's going to be 4 times 3, which is 12 in this case. All right, we move on here. We are going to have plus, we integrate, we add 1. So this was going to be a 3. It was going to be 3x to the exponent of 3 over 3. This one and this one was going to cancel, which was going to give us x to the exponent of 3. 7x, this is 1 plus 1, which is 2. So it was going to be 7x to the exponent of 2 over 2 in this case. This one is a constant, so you simply multiply by x. So it's minus 31 over 3x. Then we add the constant of integration because we are saying we are having another constant. The last time we used the a, so this time we are going to use a b in this case. So this is how we play around with our constant. So if we check here, our constant was a. This time our constant is b. And also with the same condition that we are seeing here, we are having y with respect to x. So in order for us to find b, because we need the particular solution, we are supposed to take a condition this time where we are given a condition for y on our values, not dy dx, but for y. So we're going back here on our values. There's a condition that we are given for y because there were two conditions here. The first condition was for dy dx. The second condition, this one is for y. Y is equal to 2 and x is equal to 1 from this condition here. So this is the part that we are going to take at the end to say x is 1 and y is what? Y is 2. So we are simply going to substitute. In place of y, we substitute a 2. In place of x, we substitute a 1. Then we can calculate the value of what? The value of b. So that's it. In place of y, we said y is 2. And where there is x, you're going to put a 1. Wherever there's x, wherever there's x, wherever there's x, you put a 1. So if you are to simplify this on the right-hand side, everything, you were going to obtain negative 23 over 4 in this case, plus our constant b. So we can transpose this to the other side of our equation so that it can be a positive. So that will be 2 plus 23 over 4, which will be equal to b. So that thus we obtain the value of b in this case, whereby our b was going to give us 31 over 4. So with this part now, we can conclude because what we need here is a conclusion of this part because we determined our b. So we need to conclude now to say, therefore, our y in this case is going to be written as, remember, that's x to the exponent of 4. So you can write it as 1 over 12 x to the exponent of 4 plus x to the exponent of 3. Then we have got plus 7 x to the exponent of 2, which is same as 7 over 2 x to the exponent of 2 minus 31 over 3 to x in this case. Then we have got our b in this case, whereby we got our b as what? 31 over 4. So we just have to write as it is plus 31 over 4. So this is the particular solution. That is, sometimes they might ask the same question as express y in terms of x, given this information here, given this whole information they gave us from this part here. They might ask us now, express y in terms of x. Instead of asking them direct to say, determine the particular solution, they'll say, express y in terms of x. The same concept is the one that we applied, because at the end, if we check, it's an expression that we have, it's an expression of y in terms of x at the end. So meaning to say, the same question could be asked in another way. We simply have to apply the same concept. So know the difference between these two. Working with the second order derivative, you have to differentiate throughout until you obtain y. But working with the first order, in this case, this part, it was of the first order. What you need is to separate your variables. So work with the condition that you are given. How are you going to separate? Sometimes it's not by factorial, sometimes it's direct, sometimes you just work with the condition that you are given. All you need is to separate such that what belongs to y must have dy, and what belongs to x must correspond with x. That is the condition of what? Of the linear part, whereby this part is having what? It's a function of y. This part is a function of x with respect to x, with respect to y. Once you have this part, integrate now both sides. That is the condition of what? Of the first order. The second order, you're just integrating. You integrate the second derivative, you get dy dx. If you integrate this part, the first part of dy dx gives us, of the second derivative, give us dy dx, but you must first express in a condition whereby you are able to integrate. That is why you see we had to simplify this part to obtain something that we can integrate direct, that we can see properly. So these are the steps that you are supposed to work on and revise on. After finding your dy dx, substitute the values from dy dx and x, because you are given dy dx. After finding the value of a, substitute back that value, integrate again. The moment you integrate dy dx, you are obtaining y. And here we are now having another constant, which you are going to substitute, which you are going to get from the value of y. You are now taking a consideration for y with the value of x. So that is, you end up with your b, and don't forget to write your final solution at the end. So that's it, guys, on our differential equations. We shall see more questions as we move on, but for now, that's it till we meet again.